Hello, class. Right now, we're going to go over the notes, review greatest common factor and difference of squares. Okay, GCF and DOS, they are acronyms for greatest common factor and difference of squares. So if you see GCF in a problem, that's what it means. If you see DOS, it means this. We started class by reviewing that factoring is rewriting an expression as a product of factors, meaning that if you factor something, your answer is going to have factor form, something times something else. And a lot of times it's parentheses times parentheses. In example one, we did some factoring by greatest common factor. And in class, what I did is I broke down the problem into its factors. And then if you have a factor that they have in common, you can take it out. And anything else that's left over, you can write inside the parentheses. So we did that with 3 different problems. If you can do that in your head, you can go straight to the answer. That's okay. As long as your answer, when you distribute, 2 times 2x gives you 4x, and then 2 times 3 gives you 6. If when you distribute, you can go back to this form. Okay. Remember, factoring and distributing are opposite operations. So over here, we factored and got this answer. If we distribute this answer, we go back to the original. So in example 2, we were talking about distributing, and specifically distributing factors that have a positive and a negative number. So any factors that are in this form, okay, you can actually do area model, box method. You may have learned it as a box method. X plus 2, x minus 2. You multiply it out, the middle terms cancel out, and then you get x squared minus 4. Same thing with x plus 3, x minus 3. You get x squared minus 9. Okay. From here, we realize that there's a pattern. If you distribute a positive and a negative of the same number, the middle terms cancel out. They always cancel out. Okay, if you have a positive and a negative of the same number. So your answer is always going to look like a binomial like this. So difference of squares uses this pattern in order to make our factoring life easier. So if you have factor form, the middle terms cancel out when you have a positive and a negative, and your answer looks like this. Also, if you go backwards, instead of distributing, if you're factoring this, so if you have this and you're factoring, your answer looks like a factor times a factor. Okay, a plus and a minus. This is called a difference of squares because you have a difference, meaning there's subtraction, squares meaning something squared and something squared. Each of these are perfect squares. The perfect squares, if you might remember, are numbers that you can break down and take the square root of them, and it's a nice number. So 1 times 1 is 1, 2 times 2 is 4, 9, 16, 25. All these are perfect squares. So if you see these numbers in one of these problems, it probably means it is a difference of squares, as long as there's a minus in between. So then we did some examples of factoring using the difference of squares. This is a difference because it's a minus sign. X squared, 6 squared, difference of squares. So you use the pattern. X times x is x squared. 6 times 6 is 36. And you put a plus minus using this pattern right here. Same thing with this one. X squared minus 100 is x plus 10, x minus 10. Because 10 times 10 is 100. You do a plus and a minus. This is a difference of 2 squares. 4 squared minus 9, there's an extra coefficient right here, but it's a perfect square. 2 times 2 is 4. X times x is x squared. 3 times 3 is 9. So this is a difference of perfect squares. Therefore, you can factor it like this. If you have one of them is a perfect square, but the other one is not, you cannot do it. It's not a perfect square. X squared plus 25, even though these are perfect squares, it's a plus sign. It's not a difference. So you cannot use difference of squares on either of these two problems. This last example, it's not a difference of squares yet, but what you can do is take out the greatest common factor first, and then you're going to be left with the difference of squares. So sometimes the problem has 2 steps. Always do GCF first if you can, and then you may be left with the difference of squares that you can factor out like this. Okay, that's what we did today. Thank you for watching.